You're ready to go, yep.
Yeah. Okay. Hi. Thank you for everyone for joining. I would like to welcome all of you. My name is Ajani Runavardhana, and I'm the founder and CEO of Hybrid Education, through which we are organizing this webinar today, focusing on 3D printing and design. So you can get an idea about how to use 3D printing and what industries or how it's applicable in your field or in which fields that's currently using it mainly in Sri Lanka, but we're actually focusing mostly today on the dental profession a little bit, but also like in terms of labs, how we print and design certain things, because Charlie's conducting the session today. And I would just like to give you a little bit of information on hybrid education before we start. So at hybrid education, we mainly focus on knowledge sharing and student consulting and creative consulting. So when it comes to knowledge sharing in the form of the sessions like this we do today, the webinar, we aim to bring information and awareness and knowledge regarding technical subjects as well as creativity, how to enhance your creativity, how to be innovative, how to think outside of the box, and also how to use or learn skills that you can use practically and how it can be changed, how can it be used interchangeably as well. So we've been doing our knowledge sharing for the past few years in terms of the webinars, and we have workshops, physical workshops. Some of the sessions we've done is mostly focused on the aerospace end, so a bit of RC model planes and training on that end. But at the same time, we've had a few webinars prior as well on automation, on aerospace design engineering, and also we also happy to help students with finding placements for affordable and accessible universities in Sri Lanka and abroad, mainly abroad. So we'd actually like to call upon or like show how who our main partner for academics is Manipal branch in Dubai, the Manipal University. They're an official partner. So if you or any of the students are looking to study and pursue higher studies abroad, you can always inquire or talk to us. They have fields from engineering to media and communication to business across the board, and their programs are highly standard-wise. It's in a high standard, as well as Manipal is also known mainly in India, but the branch in Dubai is also of the same standard, and they're also accessible in terms of the tuition fees and the perspective on the programs and how they accommodate students is actually pretty good to get to know as an option for your studies. So I would like to welcome Charlie,
Hello.
who's joining us today. So for everyone, just to know, Charlie is a dental technician, but he's also the
Yep.
founder of 3D ProTech. And so Charlie and I met back in Sydney, maybe back in 2017. And since then to now, I think he's been one of my constant friends across, though we haven't not been in the same country in a long time. Managed to keep in touch. And since the day I met him, I've realized that like he's good at pretty much, he's a fast learner, very adaptable,
I'll
and
try.
very quick to learn. So I would say he's somewhat a jack of all trades, where you give him a task, he'll probably figure it out, whether it's on the dental technician end, whether it's automotive, or anything that you can fit. And he's also a great chef. So yeah, and I think Charlie's originally from France. He's graduated with an electronics diploma from the school Raymond Poincaré. And I think later he followed 4 years of dental school at Cepal, where he also worked a little bit in France, I think for 1 year before he moved to Australia.
Yeah.
And since the time, I think, in Australia, he's been been in the dental profession for like 9 years. And he also had become even more and more great at 3D designing, scanning, and printing. So he's been helping companies and industries across Australia for the past few years. with finding innovative solutions through 3D printing for any sort of repair design improvements that they require.
Mm.
So I would like to welcome Charly today to share his knowledge, and thank you, Charly, for taking the
Thank you.
time to. Yeah.
Thank you. Thank you
I
for
would
having
just,
me.
yeah, I would just like to start with how a little bit on the background of how you got into the field and what it was
Yeah,
like for you to move from France to Australia.
sure. Well, look, I done a few years at school before. Well, back then was roughly 10 years ago, something like that. The 3D printing wasn't as known as it is now, and the technology wasn't quite there yet. That's pretty recent, I would say. We got really good for the past probably 4, 5, 6 years, not even. So I barely. I mean, I was already in Australia, but it got more and more accurate and affordable for the past 4 to 5 years. So at the beginning of 3D printing at school, I learned a bit of 3D design and computer, but 3D printing wasn't quite there yet, unfortunately. So this is when I migrated to Australia that I really sort of got into digital areas a bit more. Before it was a bit more sort of analog and physical models, work with your hands first, but now slowly we're merging into more digital space. So dentists and labs, they're investing heavily into new technologies to move on to full digital systems nowadays.
Yeah, and I think we would just give a brief on what exactly you do and what 3D printing looks
Yeah.
like in the sense of, so pretty much starting off as 3D printing as a dental
Mm.
technician, and then we'll go more into the.
Yeah, sure.
Yeah.
So, what we 3D print now as a dental tech, we started off by printing 3D models for the past probably, yeah, roughly the same sort of time, 4 to 5 years. They started rolling out some new dental scanners, which means the dentist can start the patient's mouth live and send the file to the lab. So, what we can do with the file is we can design the teeth on it, or it could be a mouth guard, or it could be anything else. It could be even an implant.
Yeah.
Then from that, we can 3D print the actual patient's jaw out of plastic. Then we can work on it. So they started off by that, and the last 2 years they came up with new materials that are biocompatible. That now we are able to 3D print teeth and issue it into the patient's mouth. So this is we've became from a tool to help to an actual tool to finish the whole job.
That's pretty cool.
Yeah.
Yeah.
So usually what we were doing is, to start with, we were doing all these jobs through dental impression. So as you can see in that video, the dental nurse or the dentist were taking an actual impression from the patient. So this powder here that you see is actually the alginate that get mixed to take an actual physical impression, which is like a negative mold of the patient's mouth. So that was the physical traditional way how I learned at school how to do it. So you had to mix it in, put the tray inside the patient's mouth. You probably had some impressions taken. That's not very, very pleasant to have this like gelatin in your mouth, but that was the traditional way. Now slowly we're merging into digital. From that negative impression, what needs to be done now, because we've got a negative mold, we have to create a positive mold again to actually have a physical representation of the patient's mouth. So we have to, this video, let's just click play again, have to mix a solution from water and plaster, which is stone, sort of the same sort of cement where you can find this sort of cement when you do a home, or you can do art. It's a bit like clay. And then you can actually realize a 3D designs, a 3D model on it, a physical model that can work on it. So you see, you pour this sort of solution, it's liquid, and it takes roughly 45 minutes to set. Then you'll be able to create a 3D model. Let's see on the next slide, like this one that you see here. Let's just click pause on the next one.
That's good.
So yeah, that's this sort of mold that we have now. It's ready to scan or even directly work on it. So this is how the traditional way was done back then. Now what we do is, if you zoom out on that video, we have some 3D scanner. So slowly, slowly it evolved into digital area. So now we're able to scan accurately this model, like so. So it takes a few frames every angle and then recreate the actual physical model into a digital file. So this is where we came from full physical to half digital. And now slowly these boxes here that you can see on the screen is being replaced by an actual dental scanner, which means when I'm not going to have to re-pull that model that you see in the middle of the screen, but the scan will be taken directly through the patient's mouth.
Oh, okay, so that step is totally like
That's right.
not
So
needed. Yeah.
it's not going to be needed. Probably, I mean, still now people using these sort of scanners because it's like the internet. It took a few years to sort of get into everyone's desk and everyone's study, but now we slowly merging into full digital workflow. And what we see here, that box is been miniaturized by not a box, but now more towards a pen. So we can scan patient's mouth directly and get the file into that special portal or even email. And we can start working on this file. So when we scan this file, we can recreate a digital file on the screen.
Yeah.
To actually design what we want. So for example, on that video here, we see that the patient's mouth is in blue and the white teeth are his new smile. So now they became yellow because I'm moving them. So this is exactly what the patient wants. So we've got different libraries that we see here, and we can reorganize the teeth how the patient wants. So this patient used to have teeth on the upper jaw. After the surgery is had none, and we have to reconstruct that new smile. So we have tools, 3D tools and 2D tools to integrate photos and smile lines. So this line that you see here is the line that we want to recreate for the patient's new smile. So we're reorganizing all the teeth with a photo, and we can have a sort of a 3D preview of the patient's new smile. So see how it sort of moves. We can individually move the whole smile or the whole mouth. So this is another step, another job that we can see here. We can also recreate the actually gum, the little soft tissue that we have here. It's not only teeth. Now we can recreate skin. We can recreate the gingiva as well. So that's the full lower that I recreated here and one part of the upper. So it could be one single tooth, or it could be the whole mouth. It could be the whole mouth with a pink. And we've got one part the teeth and one part the pink, the gum. So that's a real time lapse that we can create as well. So we can also freeform each tooth as well, just to add where the patient will be contacting the other jaw, because everything has to be balanced. So it's like a bit of work of art with, instead of carving into wax as we were doing before, now everything's on the computer. So we've became from fully manual to fully digital in probably 5 to 6 years now, which is pretty quick. I'm just adding, removing, smoothing, and we've got the smile.
Yeah.
So that was the sort of design that we do here in the lab. So these two little objects that you see, they are 2 implant bars, which means the patient had no teeth left. So we've recreated an implant bars that linked all the teeth in one item, in one object that we can screw into the patient's mouth. So in that way, all the implants are screwed in secure, and that job here will probably be issued in a very, very short amount of time. We can do this full mouth in a few days now, compared to before it used to take a few weeks, or at least 1.5 to 2 weeks. Now we can issue these sort of big jobs in a matter of a few days. So we've got the implant, the titanium bar, which is biocompatible. We're still using a lot of titanium, and the teeth color on top. So the teeth could be either plastic, could be a resin actually, could be composite, or it could be porcelain, or it could be also zirconia. So these sort of working with different materials, but it's always around the implant. It's always going to be titanium. So we have these two big bars. Later on, we've got two little teeth that's been designed on the computer. So this software that you see here is a software that we use to mill the teeth. So we're actually, with a small machine, a small burr, carving out all the areas that we do not want to have a final product. So each step that you see on the list is just instructions to the machine, what to do. So we're gonna have the roughing. So if I click on transparent, we can see what I've designed. So there's two little transparent teeth, and we want that out of zirconia. So each little line that you see here, they're actually the line that will follow the machine with the burr. So the burr will go inside that block and dig slowly from top to bottom, and then from the other side as well, slowly, to carve out that crown. So that was method number one. Nowadays, it depends on the material, but this material is, I think I made that through glass. So it's either glass or zirconia. These two were carved out of these blocks, but nowadays we can 3D print hybrid material, which means it's half plastic. So if I click pause on that video, see each line, it looks pretty cool. I'm not sure about the resolution you have on your screen.
It's pretty clear.
Is it clear? So yeah. Each little line that you see here, that's the actual tool path. So it's exactly where the machine will go and follow that line slowly from the bottom to the top to actually get enough space to glue that crown, which is basically like a little cap, to glue that crown onto the patient's mouth, the patient's prep.
And zirconia is zirconia. You mentioned, is it a material or the
zirconia? Yeah, zirconia is a very, very hard material that looks like a tooth color. Now they're doing multi-layer, so it really imitates the actual structure of the tooth. We've got also glass, so which is basically the same sort of material than the windows you've got at home, but instead of being transparent, you have an actual tooth color, and you have a gradient as well. So it's pretty opaque. If you look at your teeth, you've got an opaque area on the base, and the more towards you go towards the end, the more you go transparent on it. So you've got a sort of a gradient color throughout. So that's the one type of the machine that we have. Forward. So we've got a big machine. That's the machine here that we use to mill the metal. So it's water cooled. So we spray a mix of water and oil to actually mill out, to carve out what we want. So these item is an implant part. Another small milling machine is carving now Emax. So that's glass. I'm not sure if you got the sound. I have a bit of sound actually. So through these burrs, the burrs that you see on the side, they're actually little drill bits. Let's just rewind like that. Oh, that's good actually. And we're carving out slowly. I just can rewind 2-3 seconds. So if you zoom in, it's carving out slowly all the material that we don't want to make the final tooth. So that was method number one. Method number two is doing dentures like that you see on the screen, but by using 3D printing. So what we see here, we've got the base that we can print in pink to imitate the actual patient's gum. That's the patient's gingiva. And the tooth color, because we don't want the teeth in pink, we just want the tooth in white. So we can design whatever we want, whatever setup the patient wants or likes. Then we can have these two parts ready to assemble. So we've got the top part, we still have to shape a bit, and we've got the bottom part. So now what we have to do now, we just print everything and we just glue them together. So we have the base and the teeth that we can glue on. It's nice and accurate. They nice and stick together. And then you just cure it with UV. So usually with these printers, we need very high resolution printers. And to use this sort of resin, we have to use resin printers. We can't use filament for these ones yet.
With the UV curing, it helps set the pretty much prototype into place.
That's right. Yeah, it just really helps securing the bottom, the top, and the bottom part nicely. So then after that, you got a bath that you see here on the video. You submerge the whole thing in glycerin. So you make sure you remove any air to avoid any porosity, and then you cure it. If we go back a bit, you cure it. So you close the lid. There's a UV lamp inside as well. So you re-cure it again throughout, just to make sure everything is fully cured inside, because it's gonna go through in the patient's mouth. So it's really important to have a resin that's fully cured. So that, and we've got the final denture.
I had one.
So that was saying.
I had one of them before they did the permanent implant.
Yeah, we're doing nowadays on a daily basis. So this is what I've created in the lab. That's what I get every day. I get the same sort of material that you're gonna see here. This sort of plastic that I print here, they are just scans at the beginning from the dentist. And I'm just recreating these sort of models out of plastic just to work on. So this is the actual build plate that comes up with the models on it. So on a daily basis, that's roughly what I do in terms of models. So we've got the models ready to work on and place. We can place the fake crown on it, work on it, adjust it, because it's never really 100% yet. We still have quite a lot of human step involved. I don't know how long it's going to last, but we still need to sort of finishing and polish. The machine doesn't replace us yet, but maybe it will. Let's see if you rewind a bit. So that's something that I've printed as well, the top part and the bottom part, which is titanium. So that will be, this small little bar will be screwed in the patient's mouth. And we've got the top part. So it's just fresh off the printer. It's all white, but it'll be stained. I'll be painting on top the actual tooth color to have a bit better color, and then the pink as well, because we've got the pink as well here in the way. So that was a little quick presentation of what I do at work. And yeah, if you've got any question, Ajay.
Yeah. So yeah, I think just a fun fact I think you mentioned to me was that I realized so that like teeth also is different from each part of the world, and
That's right.
You can kind of gauge which area, like part of the world you're from, and the age by looking at the teeth. So
yeah, that's right. We've got all different teeth. Yeah.
And also, yeah. So moving on to like what actually is 3D printing, we can maybe give a bit of light onto what's a 3D printer.
So 3D printing is a machine that allows you to create your 3D design into layer. So it's basically an additive manufacturing process that builds actually your design into a physical object by just adding on top of each other a material. That could be plastic, that could be metal, that could be ceramic, that could be cement. Now we can 3D print houses. So yeah, it's basically adding layer after layer a material on top of each other to create an object.
And I think the next slide would show you like a little bit of the
yeah, we've got the filament printer, time lapse. So that becomes from a 3D object in the computer, it becomes a 3D physical object with. So you got, that's a bit accelerated. It doesn't go as fast yet. But yeah, we've got the nozzle here that injects slowly the plastic. So it's slowly going up. We can't tell here because the layer is probably very thin. Still can do thin layers. But yeah, it's just creating an object slowly, each little layer, and going up between each layers. So that's what we have. I
think I wanted to ask you a little bit on the So, for example, like when you founded 3D ProTech,
Yep.
so I think the type of requirements or like the requests you get for the printing or the scanning or the design in itself, depending on that, I think just to give an idea of like you start off with the design or initially the scanner, and then
Yep.
depending on the requirement, like what type of what do you call output, like what type of requirements do you actually like get requested for in the sense of
Mm.
from like maybe small parts, or like do they have is there like a range of depending on the 3D printer how much you can do,
Mm.
like the model wise, the scale wise?
Yep. I mean, what I'm doing at 3D Protech is it depends what people want actually. Sometimes they just want the design, they want to 3D print themselves. Nowadays, 3D printers are becoming very, very affordable. So people nowadays, you can send them the design and they just print it in the lab. So I've been doing mainly designs. Could be even patient's new smile design. I could be doing some accessories for their milling machines.
Yeah.
I do sell also milling machines. So sometimes when they need to fix something, instead of ordering the part overseas, sometimes we can then create the actual part in 3D and print it to fix it. So it could be anything between uh, small parts to clip a part, clip a little motherboard, or it could be a soft filament to design in 3D print vacuum hoses to plug into that machine just to fix it. So that could be that. That could be a tool holder. That could be some little mount to get the patient's burrs into a little mount. So that could be something the lab could be interested to use. A little burrs holder. That could be a little mount. I've created some mount for motorcycles. All sort of stuff. All sort of stuff.
Okay. And I think we'll just in the sense of I think on this slide we're talking a little bit about how what made 3D printing revolutionary, like, and I think you mentioned earlier on also like how over the years, like you couldn't earlier put the like do the implant directly
Yeah.
onto a patient's mouth, but I think it's been sort of advanced in a way that we get to sort of do everything in a more cost efficient way as well as like time wise. But yeah, you can tell a little bit on that.
Yeah, sure. I mean, now 3D printing becoming very, very popular, very, very easy to do now. There's like all these Facebook pages, YouTube videos, how to 3D print, how to learn, how does it work, and it's very, very cost efficient. It's very, very cheap to buy a 3D printer, even cheaper than a milling machine. You do not have any waste because milling machine you have to carve out to cut through the metal. It's noisy and you have a lot of parts that you have to replace because you have a wear and tear out of these burrs. It's very quick, so you can do a prototype design on your computer and print it the next day or the same day and get it back in the next half an hour, 1 hour, 2 hours, depends on the size of the object. Sometimes you have to wait a few hours if it's a complicated part or big. But yeah, it is very, very accessible, very, very easy, and it's very, very easy to customize as well and modify your design until you are happy with what you have. So yeah, it's very, very easy and cheap compared to traditional way of manufacturing, I would say.
Yeah. I think, yeah.
So yeah, to go back here, I've got little. So yeah, the aspect. So yeah, as I said, yeah, minimal waste, significant material loss for the milling because we have to carve out. It's noisy. Doing a mold when you're doing a product or prototype that you want to start a production, you will have to do a mold for injection molding that will cost thousands of dollars, if not more than a few thousands. Sometimes could be up to even $100,000. And if you're not happy with your design, then it has to be changed, which means you have to pay again. So that's another different sort of cost to add. These sort of designs is never straightforward. You always find yourself happy with the design, and the next day or 2 days later, you just think, Actually, I just want to modify something again. And then you never finish anyways. So it's always nice to 3D print. Make sure you look at your design physically, because Zoe looks a bit different. Sometimes you see something on the computer there you like, and in real life, you just realize I should have done it differently. So it's always nice to re-nest, re-click, and restart a new project, and you just basically spend $5 to $10, not even. So that's a very easy. These materials are very easy to handle. It's very quick. We'll see it later when we use PLA. It's a very light plastic. It's very easy to print. It's very cheap. It's got probably all the pros and cons that you can wish for, pretty much.
Yeah.
So that's to go briefly compared to the old process. So that was before. So if you see here on the screen, that's an injection molding diagram, the little draw. So an injection molding is actually a mold that you see here. That's the little square that you see in the middle of the screen. That you will have usually, you get two parts, A and B, that are linked together, and there's a piston in between that will inject the actual melted plastic or melted metal or melted silicone, could be different materials, to this cavity here, which is actually your negative design. So from a 3D design that you have on the screen that you want to design or you've designed, a factory has to create this negative void that you have here, just in order to get the plastic trapped inside. So you get the plastic injected, let it cooled, and then pops the plastic out of that mold. So you're going to inject it, make sure it's all fine. They usually, this is sort of a very easy drawing that you see here. The actual design looks more towards this sort of threaded rod that you see here, which is a little bit, it looks a bit like a propeller that you would see on boats or anything like that, on water pumps, which is sort of the same. But instead of pumping water, it just pumps plastic pellets, goes inside that tube, gets fed through that nozzle, and injected at the back here. So they get melted here, injects it in, cools it down. So that's where the cavity is. And then the mold opens. And then we've got a part coming out. So this is exactly what factory do on the industrial scale. It is very good and quick, but it's not very, very affordable, unfortunately, especially when you want to do a little 3D project and you probably need 1 or 2, 3 parts at most. You don't need the thousands. Usually they're going to ask you to order a few thousands of units to start that project, otherwise it's not worth it.
Yeah.
So we've got here the main types of 3D printing. So there's different 3D printers already in the market for you guys that everyone can sort of buy. Some of them are more expensive than others. So we have the first most popular printer that you can get in the market. That's called FDM printers. It stands for Fused Deposition Modeling. So it's basically the printer that you see here on the right. That's the little bamboo one. That's probably one of the most popular printer that you can get at the moment. They're everywhere online now. Everyone buys these sort of models. They're probably one of the best out there now. They've got these SLA one. So that's the UV light resin printers. Stands for stereolithography printers. So these printers are a bit more designed for like very, very high details models. So it's usually for labs or dental labs where you really want to get some very high resolution models, or sometimes people use it to print their mini toys to paint on it. I've seen as well. And you got finally the selective laser sintering for SLS, which means it's a 3D printer that doesn't use a filament but uses a powder container to use with a laser. So you will use powder to melt that powder into an actual product. So these sort of 3 different class of printers that we'll see. All right, let's focus on the FDM. So that was a filament printer. So what we can do is now we've got the 3D model that we like. We have the model usually exported from a CAD software. We'll see next slide what's a CAD software. We've got the file into an STL file or an OBJ, which is object file. So it's basically a 3D file that has been generated through that software. Then, but that file here, we cannot use that file with a 3D printer. It has to be sliced, which means the software has to analyze how we want the 3D file, how accurate we want to print it, and how solid we want to print it as well, referring to the material, because a 3D file just got the 3D file inside and points inside. It doesn't have any other data with the material and what we want to do with it. So we have to slice it into different slices, a bit like a pizza, and we'll get the object out of it.
Yeah.
We've got the spool, so we have to select what spool we want. So we've got different sort of plastic that's available now. We've got PLA, we've got ABS, which means yep.
So all the material, like when you say plastic, but it's still all like biodegradable ones, right?
Some of them are PLA. Yeah, PLA. We'll see that is a bit more eco-friendly than others. There is usually plastic. You could be hybrids. There's plastic with mixed with fragments of porcelain, fragments of nylon, carbon fiber even now. So they're pretty durable, but they all have different sort of settings and all different sort of temperatures and tensile strength. It depends exactly what you want, what you need. If you need to be resistant to heat, to water, to UV, each plastic can have different properties, such as metal. Metal have different properties, and plastic do as well. I mean, it depends what you want to design, but well, at the moment, I think I've been quite using a lot of PLA, and I think that's a good sort of plastic to start with. It's not very compatible with every use, but it's a good start into prototyping.
Okay.
So what do we have here? We've got the heating extrusion. Yeah, so every different plastic that you see here on the list that I'm pointing at, PLA, NBS, PETG, have different properties. They have different strength, so they have different temperatures that we can dial and print. PLA is going to be slightly lower temperatures than ABS. ABS is probably the most popular plastic that you can see. A lot of stuff are made out of ABS. Probably all the plastic you see, to be honest. Parts of your phone, accessories, the pen, your laptop. The cover of your laptop is probably ABS. A lot of stuff are made out of ABS. There's TPU as well, that's flexible. TPU, that's a flexible filament that's you probably can observe that into, see where you got these nozzles from your vacuum hose that's they look like plastic but actually a bit flexible. These ones are probably TPU. So each material has to be extruded and heated differently because they melt differently. They're different materials. So we've got different layering as well. Different printers are. Not all the printers are compatible with all the plastic, I would say, unless you want to modify them, that's all. But yeah, you have to allow the plastic to flow through the nozzle nicely and then get the perfect print out of it. So it was a bit of a learning curve to decide what material you want to use and why. But yeah, it is. Let's have a look now. So let's rewind that one. So this is another little quick recap of what we just said. The little 3D printer, so that's a filament printer that we see here. So that little part here on the top, that's the nozzle. It's just a hot end that melts the plastic slowly, each layer. So I think you can see a few lines here that looks a bit shiny where I'm pointing. So these are the layer lines. So the layer lines is between each layer, how accurate we want it to be, how high we want to go up between each layer. So the higher you go between each layer, the quicker you will have your print, but the lowest the quality will be. So this sort of here, this looks like a little boat. So the slower it is, the more accurate you'll get. So if I rewind one notch here, Again, click pause. So that's the resin printer. So what you see here with these little bars, they actually support. So these sort of printer do not have any filament attached to it, like the little spool that we saw before, but it's just a resin bath. So this bath is actually the little rectangle that you see here, black. There's actually a liquid resin inside that gets cured with a laser, and that comes out, and you get the part. And the SLA printer will go another quick videos later. That's the powder. So this item that you see here get set. They actually get melted from a laser. The laser is up there. We can't film the laser yet, but we'll go through that in a sec. So to zoom in, so that's the FDM printer. This is exactly how it works. We've got the spool here. We've got the filament getting inside the hot end, gets melted, and then we add that one onto that build plate. So each layer gets added on top of each other. So it's just all about melting. Any 3D printers, it just melts. We're using melting technology. So we could melt spool, or we could melt with a laser, or it could be set with a UV. But it's all a layer after layer. And then the next one, so that's exactly how it looks on the time lapse. So that's the filament again, how it looks. So each layer gets added on top of each other. Let's just rewind one notch. So it looks like a little art shape. So that's the LCD one. So we can see what's happening in the bath. Let's click pause again. I'll show you guys. So this is how it looks, this sort of printer. It looks a bit different than the printer we've shown before. And that's the bottle that we see on the side. So they just sell this resin into bottles. So you can have different sort of content, different plastic into different bottles. They're usually pretty similar in terms of size, resin, printers, and filament. All the resins are done a bit smaller. They also became very, very quite affordable. Now you can get probably an average size LCD printer, resin printer for roughly $200 to $800 US. So it's pretty wide, but it's pretty accurate in terms of printer. So that's the resin. So that's the bath that you see here. Let me click pause again. So you can see the item, the object that's coming out of that bath here, completely liquid first, and then gets flashed with the UV light. So between each layer, we get an actual slice out of it. So this is how it comes out. That's the time lapse. It usually takes a few hours. This is how it looks inside without the actual bath. So between each layer, every 2 to 6 seconds, it's usually between 2 to 4 seconds. Some material needs a longer UV exposure. So what we see here, that flash is exactly one flash is exactly one slice. So how it gets done. Let's rewind it not much. It flashes, stops, the build tray comes up, comes back down, flashes again, comes up, comes back down, flashes again, etc., etc. And finally, as we said, the SLS. So that's the actual powder printer. So exactly the same thing as the LCD, but instead of having a UV light, that's a laser. And the laser is just powerful enough to melt the plastic. So we have a bath here, which is full of powder. The laser here that we see melts the plastic shape that we want. Just one slice. That's the build chamber. The roller will spread some new powder, a new fresh layer on top. Comes back. We collect the excess on the side. The laser comes out again, sinterize the new layer again, gets the next slice stuck to the previous slice, like this one. New powder, sinterizing, new layer, and we flush it again here. So we've got all this powder now to clean from that object. all around. So it's like, because they were like dipped inside this big powder base, big powder bath. So you clean it and you got your final object. So powder, sinterize, powder. So this is what's happening under the microscope. So we literally, all these grain here, there's just the powder, and the laser that in the middle literally burns and melts the actual material. Oh, gone a bit too far. Okay. All right, so this is exactly how it looks under the microscope. It's okay. That's fine. And what can we do with it? Well, now a lot of people started buying 3D printers or even building 3D printers for their own industry. People start even doing cars nowadays. They can start doing a few parts of the engine bay. So there's all these parts that you see here on the screen. They're all 3D printed. So now we can literally design a car and 3D print out of nothing without having a huge amount of production line behind it as well. So these parts of that base 3D printed, not these carbon fibers one, but all these frame, it's been 3D printed out of aluminum or stainless steel. All these frame here has been 3D printed. Ford as well, the car maker Ford, they came out a few weeks ago and said they're looking to 3D printing to add this sort of process into their production line. That's sort of that part that we see here is also 3D printed around the wheels. So that's actually what fits onto the wheel with the brake pads, the brake disc. So it looks a bit weird, but at least it's functional. Is probably one of the best thing with digital is you can design the part exactly how you want it and how the force will be spread across the actual structure instead of manufacturing through normal milling program and milling machines. So we want to put people engineer now put material exactly where they need to get the part strong without having any waste of material. So that's what they've been doing on that prototype. I think that car is called the Zinger if you want to have a look online. And it works. You're doing great stuff now. Other users, you do printing boats?
I know it doesn't run at that pace, but the real
unfortunately
life scale is brutal.
Yeah, it's probably that boat's probably a hybrid, and half plastic and half fiberglass, just to be light and flexible. You just want to be light that floats. It probably took a few hours to print that boat. Probably I'd say a couple of days. People, but now at home they've got their little 3D printer. They 3D print these little door knobs. They just 3D print this little clothes hanger. That's like a helmet mount as well. If I rewind it one notch, put the helmet on it. Depends what industry, what you want to do as well. Any parts that breaks, you can fix it. So there's probably a clip that goes onto a car that someone fixed. So you just can reverse engineering, measure the actual part, and do your own on the computer pretty much. So that's what it's been doing. There's people create these little mini gearbox that they can have in a little project at school, just to analyze torque. So that's sort of the software we'll go through. Maybe if we're not running low, that should be fine. Should probably can have a quick look. What else do we have here? People create their own little gears later, so they have all these sort of gears that we can replicate as well. People can even now that we can 3D scan object, we can 3D scan animals as well, or 3D scan humans. So this dog is missing a leg. So what they've designed is they've designed a mount that clips it on the dog, a little harness. So it's got a little fake leg. It's a bit weird, but I think you got used to it. He's happy. We can create fake hands, fake foot. So that's like a little foot that you can recreate. So now we're just literally cutting the cost down by probably 1,000 or 100. People can recreate their own prosthetics at home pretty much now.
Mm.
People do designing chairs. So that's a chair that a guy printed online. So instead of buying a fancy chair online, you can recreate your own. The sad thing is that the printer wasn't big enough to do that chair, so he had to cut it into different parts. So that's sort of how he's done it. I think it was 21 parts to do it. That probably took him a few weeks to print all that. He's just showing what he's done with the body filling. So he's just fixing up the imperfections, the actual joint, prime it, paint it, and you got the chair. Pretty cool. People doing costumes or cosplay with it as well. So this guy is linking these parts together, which is the main issue. Having a printer is cheap, but having a big printer is expensive. So people usually assemble parts and do their own little build by assembling everything. So this guy just done an Iron Man costume cosplay. Some other people just design and print wind turbines. So that's one design a wind turbine, another design looks like a wing. So they've got that at home. Some others print mounts, so it looks like that's a phone mount. It's one of my favorite actually. I should print one now.
I know, I think so too. They like the design. Let's read.
Yeah, I want one now. Some people print toys, so that's a little multicolor printing from Bamboo Lab. So that's why a lot of people started buying these sort of printers, because now we've enabled people to buy this cheap printer and still have a good quality out of it. And now with these new AI and these cameras inbuilt, we can then have sensors inside the printer, so it knows exactly what to do when the filament is running out, and even print in multicolors. So the printer could print one color, retract the actual filament, inject the new color in, and print a multicolor toy without doing anything, without painting that toy. So that's been,
it just comes up built. Like ready, pretty much.
That's right. It comes out ready to play with, pretty much. What people do, and what I've done as well, is you can print over and trap parts inside your actual design. So this guy printed a little plate with voids, with cavities inside. He placed some magnets and printed over the top. So the magnets are trapped in, and he's using it as a key holder. So you could have magnet in trapped in.
Yeah.
And also start designing all these sort of designs with magnets inside if you want to get it magnetic, like for a fridge or something. That's one of the mount I've created as well, with a bolt, a nut inside. So the shiny part that you see here, I have trapped a nut inside. So it's been printed around that layer height. The printer stopped. That's in a standby position. I just placed a little nut inside, and I've clicked resume, and then we just printed over the top. So I literally trapped that nut inside to have a threaded part inside, a little thread.
Nice. I thought I was going to say, like, I used a 3D printer like long time ago back in university for my final year project. Project, I studied aeronautical engineering, so I was sort of doing flight systems too, and so pretty much I used a 3D printer and like 3D design to design a few different types of wings at the time. So this is probably like back in 2015, 14. But we still used it for like just creating. So my wings were not like, you know, in the normal aircraft you get the wings backwards. So these ones were forward swept wings. So just to see the prototype, to scale it and design, model it, like we created it, we built it through the 3D printer and then put it on the wind tunnel to test and see, depending on the angle, you know, when you have like the wind for just 0 degrees. and then a little bit forward swap for like 20, then a bit more 45, that type of thing. So
Yeah.
I think just wanted to share that, like, because a lot of my audience is usually on interested in aerospace and how they use it for just even getting a prototype done. So like I think Charlie
Yeah.
also mentioned, as opposed to manufacturing in the traditional way where it'll also cost you a lot, and then even if you want to, you know, just play around a little bit with different handles to see.
Mm.
Whereas now it's just, you can, I think, do it even faster than I did back then with the printer, because I'm
Yeah.
pretty sure I had to do, yeah. So
Faster
like,
and probably easier.
yeah, and also it'll look cooler because I still run the camber for like 20 degrees or 45, so it looks nice. It's a smooth finish,
Mm.
but I'm sure we can add like even more like, you know, like small details into
Yeah.
it. But yeah.
Yeah, now they just progressed a lot. Like every printer manufacturer, they progress so much into these 3D printing machines that you don't even have to do anything now. You just slice it, you click play, and then you don't have to do anything nowadays. It's insane. They just the 3D printer tells you sometimes if the file is good or the file is corrupted or is not going to work
Oh.
or anything. Basically they're just making it so easy nowadays that you almost cannot fail. I mean, I still manage to do it, but it becomes very, very easy
It
to
had
do prototyping now.
but I think it's like so like you said, in the ones now, like even the human, pretty much like the need to even
Mm.
overload, because the printer can run for over 4 days, like 24/7. And as long as there's enough, you know, for like filament there to run
That's
it,
right.
you do.
That's right. Yeah. As long
Yeah.
as humidity can affect that, if it's very, very
Mm.
humid, that can affect the actual filament. So usually when I have very long print, what I'm doing is I just make sure my filament are dehydrated enough. So I have a little box with a little fan inside and a little heater that heating up the
Yeah.
filament up to 50 degrees. So at least we get rid of the humidity. I'm not sure about you guys if it's pretty humid, but now it's summer in Sydney. It's pretty humid, so it's nice sometimes every few weeks, few months, just to dehydrate all these filaments just to get rid of the humidity inside.
So like, what do you do in terms of hydrating it? Like, what do you do? So if, for example, in Colombo it's pretty warm.
If it's warm and dry, it should be fine. But usually, what
Oh,
I
if it's
do,
humid.
if it's very very humid,
Mm.
before starting any big print, or when I can see some little defect on the actual item, on the actual prototype, I bought a couple of dehydration device, which is that's a little box that's exactly the size of a spool, which is roughly 24 centimeters by 24 by probably 10, and inside there's a little metal plate that goes from one end to the other. So when you place the spool inside, that metal plate heats up to I think between 49 to 55 degrees, and
Yeah.
you let it run. You let it run for roughly anywhere between 4 hours to even 24 hours. Sometimes just leave it run overnight for 12 hours, and the heat actually dehydrates the spool. You don't want any humidity in the filament. You just want to get the filament as dry as you can, to avoid all these little defects, because the humidity is small, sort of bubbles of humidity of liquid inside that filament that will be melted in the same time than the filament, and that can create a porosity issues when you print. That can create defect as well
Okay.
in the item. So it's always nice once in a while to do it. It depends how humid it is, but yeah, I would suggest, if you in a season where the humidity is probably above 40%, it probably would be worth it to run a little cycle
Mm.
of this stuff.
Yes.
So that's another little item that I've created and printed for labs. So that's a little burrs holder. So you just hold the burrs, the dental burrs that we use to grind the
That's
teeth.
very handy.
That's pretty handy, yeah. A lot of
Yeah.
people you still use that in the drawer or box. So in that way, it's a bit sort of more ergonomic way to organize your workspace, your desk. So people ordered quite a lot of these ones. They've been pretty happy with it. I'm using it myself. So we got that one. What else did we created? The little switchboard of the van that I needed with some lights. So I've got the USB buttons in here. So everything that you see here on the screen in the middle, the little black square, that actually 3D printed. So 3D printed the text as well with
the text as well.
the text as well, yeah.
Yeah, nice.
So if you go back, so this is a normal black filament where you see these items screwed in. There's the switch. I literally designed like a normal flat design, a rectangle with holes inside, so I didn't even need to drill any holes for the buttons. They were there already. I just had to plug and play, pretty much. So that's a little humidity device that calculates the humidity and the temperature. So that was a little light switch. I've got the USB switch here with the 2 USB there. I've got the battery monitoring because I needed to get a battery done. I've got the 2 little USB-C and USB-A here. So that's 3D printed.
Nice.
So that's a little quick screenshot of Slicer. That's probably one of the most famous Slicer now. We've got Ultimaker Cura. So this Cura that we use, and we'll see in the second bamboo. We probably can do it. I think we have time to do a quick slice, do a quick print before we're going on to the design. What do you think?
Yeah, I think we can start one now, actually, right away.
Yeah, that's good.
Yeah.
So so that's the actual representation of a design. So look, that's the Mario. Let's rewind a little bit. That's Mario. Here that we see, all these red areas are the areas that will be hard or impossible to print. Which means when we print something, we start from ground up. So these first layers will get laid down onto the build plate and going up. But the problem is, it's very, very hard. You always need a support. You cannot really print out of thin air. So this between these 2 areas, between the legs, is not going to be too hard to print because you still can bridge an area. If it's a small sort of area, you sort of can bridge it. But printing out of thin air is impossible in 3D printing. You always have to get real support. So these areas here, when you go up, it's not going to be available. You're not going to have any support. So if you activate the support here that you see in blue, you will have something that will hold the filament when you'll get to that layer. So if you don't have that blue part here, basically the filament will drop on the floor and you're not going to print anything. So the whole arm will be missing of Mario. So pretty much, if I can do, let's just exit that. We probably can slice it or something. You just delete it so I can show you how it looks. Probably can print. Do you want to print a turtle or?
Before that, do you want to maybe tell a little bit about the unless you're doing the design on our own, like where we can maybe sort of get a couple of the designs already downloaded, the ones that are sort of available online.
Sure, yeah.
Nowadays, yeah.
Do you want me to show you what's available online or?
Yeah, I mean, what we're doing currently, we can just show, right? Like,
yep. We can. Let's have a look. Let's just nest that and let me have a look if I can find something here. I can find you something.
And so usually for the designs, I think you can use either AutoCAD and like SolidWorks, Blender, and I think the one you mentioned today, Charly, Tinkercad.
Yeah, there's a few. There's a few. We can go through in a sec. I think this one of the next slides. I think we'll.
Yeah. No, that's okay. We can
have that one in there. So this is sort of what I designed here. Let's just open a document that I have here.
Currently, the one on the screen is the Bamboo Lab. Yeah.
Yep. So this is sort of what I'm working on now. So that's little machines that I'm doing that will open some valves for lab. So what I'm doing is it's actually a little sort of a robot arm that goes down, unscrew a little vial that we can see here. So this is all the parts that I've created at the moment. So this even I've created the upper, the lid. What else do we have? Let's just have a look from the ground up. Construction. Let's just remove that. So vials. So this is exactly what I need to open. Looks like a little vial.
Yeah.
And we've got the motor that gets mounted on the plate that turns the actual vial counterclockwise. So that's actually the little guide rail that goes down, up and down through that motor here. So this lab needs to do that and needs to pour later. Well, that's I'm probably between 20 to 30% into that design, but I'll try to finish before probably February, March, maybe, if I'm lucky. Still a bit of work left, unfortunately. So we've got that one here to open, unscrew, and tip the actual content of the vial and drop into a bin. So that's a little project that I've took on around November this year. So I'd like to finish in the next few months before someone else wants to put another order. Yeah. So this is sort of what I'm doing here. So that's the gears that I've designed it here. So if we remove the vial here, that's exactly how it would look.
Yeah.
Just remove the lid. So we've got this little motor that turns this gear clockwise or counterclockwise. That will turn these gears to grab the actual vial in the middle, to squeeze it, and unscrew it like a hand.
Yeah.
So this is one of the sort of design that I've been working on. That was another design with I don't have it on my computer, unfortunately. A little snorkel for a Porsche Cayenne, a little four-wheel drive. I've done a rack for another lab. That was if I cannot find it here. Let's have a look if I have it here.
We'll also put the print on, I think.
Yeah, we can. Yeah, let's switch it on. What do we want to print? Do we want to do a little? I've got this little turtle that I just downloaded. Do you want to print a new turtle?
Yeah. That's
cool.
I think we will show where you can get some of these downloads as well. Like if you're not designing yourself,
I'm gonna show you. I'll open these the other page as well. So what do we have here? That's the slicer that I've been talking about. So the slicer, it looks a bit hard to understand from the beginning. We've got a lot of options here, but it's basically a software that will convert this 3D file into a file that you can read with a 3D printer. So these sort of file that you have here, they look like exactly how they've been designed.
Yeah.
And so we've got the quality, so we can set up the actual layer height. So it's the actual height between each layer. So if you zoom in here, how do we want these items and how high we want to get that quality? Do we want a good quality? So the layer height will be thin. So the thinner it is, which is exactly, when you think about it, it's exactly how it looks when you take a photo. When you take a photo with a phone, you have pixels. The less pixels you have in the camera, probably the quicker you get the photo out, but the less you'll have just less quality. So the more pixels you have, which is like here, you got a lot of pixels. Yeah. If you convert that file into a thick layer height, you will have a good quality. So it's basically here, you got all these values that you can change. You don't have to change them all. They're usually preset. I don't change a lot of them. I just change basically the layer height first. That's what's really one of the first sort of settings that I sort of dial or fine tune. Lay height, so the normal sort of standard lay height that people print is usually 0.2 millimeter, which is not that big. 0.2 millimeter is if you take a ruler, 0.2, imagine you cut this millimeter into percentage, and that's 20% of a millimeter, so that's pretty thin. You can go even up to, I think, 1.18 or something, 1.19 nowadays, I think is. Yeah, 18 is even 15. Yeah, that printer accept even 0.08. That's 5, yeah. So 0.05, that's the limit, I think, which is not that. 0.06, I think it was even 8. I haven't been printing in that yet. Let's see, 80. So that's pretty thin. 0.008, 0.08 is 80 micron, IG. 80 micron
okay.
is a little bit thicker than hair. Human hair on average is 65 micron. So we are able now with a small cheap 3D printer to print a little bit thicker than a human hair, which is pretty good nowadays. The printers, they got very good very quickly. Let's just set it back to 0.2.
Yeah.
We've got the strength. So how many walls do we want? So how many walls of filament do we want? Because now that we have this 3D object, what do we want inside? Do we want a hollow? Do we want to have a big hole? Or we want a thick wall?
Fill it in. Oh, okay.
That's right. So usually these settings are what's inside, what's going to make this part strong. So we have the actual wall loop. So this between each wall, how many sort of lap do you want to get the machine in terms of strength? So we've got that one, we've got the walls, we've got the infill. The infill is how you want to fill up the actual part.
Yeah, I just want to say, like, anybody, if you have any questions, while Charlie's going through this, you can always just raise your hand if you want to ask, or you can just type it in the chat as well. Yeah. Can continue, Charlie. Yeah.
So we've got the infill. So the infill here is the actual geometry, the actual pattern that the machine will follow to fill up that gap between each wall. So we cannot print something like that completely empty. It has to be with an infill inside to have support, because it looks like a complicated geometry. We've got the shell that's on the top. So that one here, you might need a support inside, which is the actual grid. That's actually the infill that we have here. So that's the percentage you can set. So the more percentage you have, the more plastic you're gonna have. So the stronger your part will be. So if it's for prototype or aesthetic, you probably don't need to touch that too much. You probably can leave it around 15%. But if you want something very solid, then you can add an extra wall, which is an extra 0.42 millimeter of extrusion. So that's the actual thickness of that wall. So if you have two walls, you're going to have 0.42, which is 0.84 millimeter of wall thickness. So that's what strength means in terms of wall loop. We've got the speed. I never really changed the speed. They're pretty fast enough anyways. We've got the support. The support are for complicated parts where you need to integrate a little sort of support file into that object, so we can print not out of thin air, but we can have a little base to print out of.
Yeah.
To avoid any failures. So if you want to have a quick look here at the slice, let's just click slice plate. We can have it now. This file has been converted into, it doesn't look like a turtle anymore. It looks like a big sort of little mountain, a little pebble. See these lines here? They're actually the layers. So this is exactly how it would look like. So the machine will start from ground up. It will start by layering the first layer, like that. And then slowly going up between each layer. So this is exactly how it will look like. So we've got this gap in the middle. We've got this wall on the outside, which is two walls, as we said. So we've got two little extrusion. Okay. And what we have here in the middle, as we said, that's actually the strength of the object. That's the actual infill. So we've got the grid, so that's how it looks inside, looks like a grid. And we've got 15%. So which means inside that object, only 15% will be filled. So if you combine the surface area of that surface of that grid, you're only going to have 15% of plastic inside. If you put 100, that object will be completely full. So you just click slice. Now see that object became completely full. So it will be very heavy. So when we compare now, total time here down the bottom, we've got 1 hour and 5 minutes. Yeah. Total time to print. The cost, it will cost roughly 62 cents. Okay, of I think it's in Aussie dollars, not in US dollars. And what else do we have now? If we change back to 15%, so we'll imagine actually we've got 1 hour and 5 minutes back to 15%. Slice again. And now what we have 41 minutes. So it's 20 minutes quicker.
Yeah.
So we just save time, and from the 62 cents of cost, now it costs 26 cents. So we just got to, usually when you get prototype within the injection molding, whatever you want your final product or you want a prototype, it will cost you the same amount of money. So the cavity, what's inside the actual cavity, will be untouched. Like you cannot dial the actual plastic inside. You cannot inject less plastic, otherwise the part will be unfinished. So we can reduce, what we have now, we can reduce the scale. Yeah. So make it quicker. Let's put 50%. So 50% is pretty small. Let's just stick with 70. Slice again. And now we have 70% of the actual size of that little turtle. Yeah. So it will only be 25 minutes and 23 seconds. So it's going to start with this layer and going on the way up like that, ground up, to complete that turtle. All the way up. And that will cost only 11 cents. So that little turtle will cost of plastic without the electricity, etc., and the maintenance of the machine, but just the plastic will cost 11 cents, which is pretty cheap. Yeah. We probably can print that actually. You just click print. So now let's just send that one into the machine that I have. Okay, send. And it's gonna load into the next page. There's a camera inside, so we'll be able to follow that actual print. So that's downloading. There's a little camera inbuilt inside. So that's downloading. Okay. Does anyone has any question, Haji?
If anybody has any questions, you can.
Not yet.
No, I don't think we got any. But yeah, can put it on chat as well.
Yeah, I don't think I've activated the chat. Let's have a look.
Not into that, but we haven't gotten any messages yet. But it's oh yeah, you can see inside the printer now.
Yeah, that's it. So I've got the camera. So now what it's doing is heat bed preheating. So it's going to preheat the actual build platform. So that's where the little nozzle is. Can you see my mouse?
Yeah, yeah.
So this is exactly where the filament will come out of. It will come out of here. You've got the little countdown here, 21 minutes left, and we have 91 layers. So we just done 0 layers at the moment. It's just preheating. And slowly we get into, we'll just go and have a quick look at the design and we'll go back. So it's pushing the new filament into the extruder. There's a step here at the back. Okay. And it's still preheating. All right, let's just go have a quick design first and then we'll go back in 5 minutes.
Yeah.
So that's another little design that I've done here for a little rack to put vase inside, just to for a lab. So that's what they wanted with numbers. So you could do all sort of project. People doing costumes, they're doing maintenance parts for machines, they're doing car parts, or they just print teeth like me sometimes, you know. Depends what you want. They just close everything.
Oh, and Steve has asked if this design software come in with the printer you use.
The design software, actually, people are free to use whatever design software you want. So you got different software that you can get. We can probably, we can go back to the slide quickly.
Yeah.
We probably can go to the next slide and have a look. Actually, what do we have? Let's have a look if I can find that slides again. Here we go. FDM. What do we have in these slides? We've got here.
Yeah, I think we can go with that one. Yeah.
Yeah. All right. We've got a few software that's available for you guys. SolidWorks. If you are a student, you probably can get a free license still, because I used to work with SolidWorks before when I was at uni, when I was cool. Blender is free. It's probably what people use the most. AutoCAD Fusion 360, that's the software I have now. That's also free. If you want to start off with a few small amount of designs, or you can create an account and open up to, I think, 8 design or something like that. If you design more and want to commercialize all these design, I think there's a little fee. Depends what country you are, but they usually ask for a fee per year or per month. There's a little subscription fee to pay. But if you want to start off free, you probably can try Blender or Tinkercad. I probably would go with these ones. If you got a few designs, but you need really sort of engineering sort of software like this one, Fusion 360, it's a good way sort of to start and get your feet into that one. I would probably suggest these 3. Have a bit of a play around with Blender and Tinkercad. You really cannot be disappointed, because it's easy to use, easy to learn. There's a lot of tutorials on YouTube,
and
it's free.
And just want to clarify with Steve. Like you wanted to know in terms of the design, or like where we had earlier doing the slicing. That was, I think, on the Bamboo software, right?
The slicing, the slicing comes with the actual printer. Yeah.
And that's the printer.
That's right. So sometimes you can download other slices. It does not mean you can you can't use anything else. Sometimes printers are open source, and the actual code is also open source. So what's important is just to get something that's compatible with your printer. Now, the Bamboo slicer that I have here on the screen, I think it's that's it. That's printing. So now is printing progress. There we go. So this software, I'm using this software because it comes out with a printer, and now it's pretty powerful. We've got all the options that people need nowadays. I think this software is also open source. They usually have a huge community online. People can also ask the designing team what they want or what would be nice for that software, and they've been listening pretty good, I would say, because all these new options that were not available now are available in the new versions. So they're doing very well with these sort of designs and this slicing software. They all sort of look the same now. We've got all these same advanced parameters here. They all work the same, and the only difference is the actual file that will be exported. So this sort of Bamboo slicer will export 3MF file. The other one could be a G code, which is basically an alternative of that Bamboo lab. But then you don't really have to worry about it as long as you got something that's compatible with your printer. At the end of the day, they almost all are the same. Almost. You just have to sort of understand how they work, how's the layout, just to get used to the software and how you want your physical final item, and then you'll be fine. There's a lot of tutorials again online. There's a lot of on YouTube. There's a lot of on Instagram, TikTok. People create these little designs and print and show their journey and how they design it as well. Some people sell the design as well.
Yeah.
So you can buy it. So you can see it live now. That's printing.
Yeah.
And we've got another 17 minutes to go. So it's already been printing 3 layers on it.
Nice. Yeah.
4 now out of 91. So that's pretty quick.
And we'll just go through the slides, and I think that we can.
Yeah, you want to go through this few slides?
I just
So
wanted
yeah,
to ask you, Chris, if you go back to that the slide before. I think. Oh, yeah, we are here, right? 3D
that one.
designer. Oh yeah, we didn't. I mean, it's the filament we're using right now, right?
That's
PLA.
right. Yeah, that's the filament. Yeah.
Yeah. So that's the
Yeah, I
one
can
that
talk. I can talk
Yeah, you can
quickly
talk a
about that
little bit
one.
about like the filament we're using. Yeah.
Yeah. So yeah, usually for every single of my prototypes, I'm using PLA, which is probably the most popular filament that you can find on internet and the most popular filament people print with, because it's cheap. You get a good product out of it. You print smooth. It's easy to print. It's probably the easiest filament to print. Is biodegradable, so it's very sustainable. It's made out of cornstarch or sugar cane. It's mainly cornstarch, so it's very, very cheap to produce, very, very cheap to print, and it's safe because it's also a filament that you print on with a very, very low temperature settings. So with any printer, online filament printer, you can print PLA. It's very, very easy to print, and yeah, it's just PLA. Yeah, it means polylactic acid. So that's probably the most used filament online. Yeah, everyone uses. Doesn't matter what country you are, you're always gonna be able to find PLA in your country. So that's what people use. If you really need other filament for anything else to be a bit stronger, just want to let you know that PLA is very, very strong, and it's even stronger than ABS.
Okay.
People think always print better plastic because it's more durable. They're going to be more solid, which is not. PLA is less durable. You're not going to be able to print this sort of plastic to put outside and expecting no degradation for the next 2-3 years. It will degrade with the UV and the rain and all these bad weather condition. It will degrade quicker than any other filament, but it will be very strong at the beginning. If it's a little quick product that you want to just print for your house or even outside just for a few days or whatever, it will be fine. For a few days, even a few months, it will be fine. But direct UV, direct sunlight will slowly degrade that filament. That's for sure. So that was the slicing. That was the factors to consider when you start a design. So when you want to start printing your prototype, PLA is fine again. But when you really consider the environment of your design, really make sure you address the list. What exactly you need out of that design? Is it going to be a design that will go outside? Is it going to be a design that will go under the UV, under the sun? So you'll have the UV degrading that plastic. So make sure you select the right plastic. It might not be PLA, it might not be ABS. It depends if you want to get that part with a lot of friction. If it's going to be attached to a motor, so you have a lot of friction. Especially if it's a gear. If that model will be in the water, so you have a different plastic again. If you need it to be watertight, it might be not the best choice. Depends what you want to do and the size as well. How big is your design? These printers are usually between 20 to 28 to 30 centimeter cubic.
Yeah.
So it's pretty big, but it's not that big. So you're gonna make sure you got enough space and your item will probably fit. If it doesn't fit, then you probably need to cut it, or you probably need to find other alternative to print. So that's these, little freelance designers. All as I said, these sort of design you can find them online. You can learn them on YouTube, Instagram, LinkedIn as well. People are willing to help sometimes with designs. Sometimes they are charging people, but if you have a small little project, they're still willing to help. These little Bamboo Studio, Cura, Orca, there's sort of the slices. Yeah, you can get ideas from.
Ones. Yeah,
that's
like
it.
Yeah, the AutoCAD, and I think they're a bit more we are acquainted with, like the design softwares, but I think the slicing ones are pretty particular, right? With the 3D printers. So I think these are some of the ones: Bamboo Studio, Cura, and Ultra that we can use.
Yeah.
But
Yeah.
yeah.
They are the most popular one. Bamboo Studio is just it's just been designed for Bamboo Labs printer, so that's
Yeah.
the one I probably would suggest for the Bamboo Lab. Cura was actually the base of any slicer. Everyone was using Cura before the era of Bamboo Lab. Like I think it was for the past. Probably Cura's been around for almost 10 years, I would say. When all these printers came out, the very cheap printers with the Ender Creality, there's another big brand that's a direct competitor with Bamboo Lab. Their name is Creality. They're doing resin printers and they're doing filament printers. So all these printers were compatible with open source and they were all compatible with Cura. With the full name is actually Ultimaker Cura. So these sort of slicing software were compatible with every printer on the market. But now that the market's growing, there's a lot of people that are interested in printing, and a lot of people buying more and more printers as it become more reliable. People sort of now start merging apart, diverting from these main slicing, and they have their own slicing for the particular printer. Orca slicer, that's another slicer that's also compatible with Bamboo Lab. But yeah, I would suggest have a look into Bamboo Studio. This is exactly what you guys need, and I don't think we just need anything else than that, actually.
Yeah, and I think, like you mentioned, the 5 and Upwork, it's just if you want someone to help you with the design.
That's right.
You can get someone to do like freelance design, whatever the idea you have in mind.
Yeah, that's good with this sort of design because anything could be remote now that we can work fully digitally on the computer. You don't even need to hang out with people that know their stuff anymore. You just can send an email and a few drawing or call someone and ask for a design. You could connect on their computer and make final touch up. There's people now, they don't even need to go to the office to design 3D printed parts now. You can get help online and get people from Fiverr or again YouTube, Instagram. A lot of people have their own little channel and their own little project. They're willing to do sometimes a bit of freelance on the side. So it's up to you. Either you can design your own if you've got the knowledge, or you're willing to learn, or sometimes you can ask for a bit of help. Both ways work.
Like the one we are printing now, we downloaded, right? Like
that's right. Yeah, the one that I'm printing now is the fact that another guy uploaded to that website. I think we'll go. I think the next slice. We've got a few websites that you guys can write down. You can even take a photo, guys. Make sure you take a photo of that website, of that page. Yeah.
You can take a photo, or you can also just, if you can, put your email or like on the chat. Well, we anyway have our Trentat details, like I think at the last slide. But if you just trend at me, I can also share some of this, and I think you also sent me some. We have a few resources that we can send through.
Yeah.
So I'll anyway.
I'll leave that slide for 2 minutes. Make sure you take that in photo. Thingiverse, printable, Col3D. Thingiverse and printable are probably the main ones. You probably want to, sometimes, you're looking for design, you want to do something or fix something in your house, but the design's been done. So you even have to design it. Make sure though, I would just say you something. Make sure though, if you really want to print something and sell it, make sure sometimes you have the right to do that. And sometimes people are willing to take a cut. So if people upload their design, sometimes it's just not available for commercial, but sometimes people are willing to say, look, that's my design, but do whatever you want with it. So it just depends. So you might want to have a look at Thingiverse and printable first. Col3D have a lot of good designs if you're into toys and miniatures. A lot of talented people in Col3D, but sometimes you have to pay for these designs. Pinshape, things.com, you imagine. So that's RC, the RC creators, people designed and uploaded some models for remote control cars. Miami Factory is good as well for these little miniatures as well. But yeah, I would say all the sort of general design that you're looking for will probably already would be in thingiverse.com or printable.com. Have a look.
Yeah, we'll share some of the links and resources. So I'm just
Yeah,
putting it on the chat as well. So
yeah,
if you need it separately, but yeah, you can also take just like a screenshot or like a photo.
yeah,
These
yeah,
ones.
yeah. Make sure you take it to a screenshot, guys. Make sure you'll be fine. Thingiverse, printable, they're the main ones again. Cold 3D, not too bad. And the rest. It's always nice to just, browse through. And I mean, Thingiverse has been going on, a lot of people, I think there's probably more than 100,000 designs already. That's a
Yeah.
good question, actually. I haven't been following that much, but every week there's like these sort of ranking, the
Mm.
most downloaded designs, the most popular designs. So some of the people actually have very very great ideas.
Yeah. And I think.
So yeah, what we have here now, application of 3D printing and industries. So a lot of industries now use 3D printing. They just started using 3D printing even for cars. Ford, because it's just for prototyping is just very very cheap and quick. Just to validate the models first, make sure it's fine. They're happy about it, and they proceed with mass production. Education, a lot of schools in uni now or
Yeah.
engineering programs started buying these printers. They became very very affordable, so people, in at schools they can buy 3D printers almost one, if not more, per class, which is very good now. Before the price wasn't that cheap, so they were sharing a printer for the whole campus. But now schools with a bigger budget have a few printers now per class, per section, which is very very nice. Custom manufacturing as well. People have a little printing farm at their place or their little business. In America, a lot of businesses started emerging as well from these 3D printers companies now as it becomes more affordable and small. They started doing printing on demand business that you can upload your file or you can already have a file available, send it to them, and you'll get your item in the next week and a half. So that's what people have been doing. Or if you have enough motivation and time, you probably can get your own little printer, start learning, and print your own little DIY project and gadgets and other creation you want to print and to fix stuff. Or there's always a little something to print. I wasn't into really 3D printing much, but since I got a 3D printer even here at home, I always have a little something to print every week. Even though sometimes I don't really need to print stuff, I still have inspiration to fix stuff, design quickly, and 3D print a little something. So there's all these applications you can go through. We've got this 3D ID. You model onto the computer, do your own little prototype, and you get little final part. So that works with the cars. That works with even houses. Yeah, people 3D print houses now with instead of having filament in plastic, they 3D print with cement. They 3D print or even organs now. They started 3D printing skin. They've been talking about for the last 1 or 2 years 3D print meat. So I haven't really seen that yet, but that should be available soon, I reckon. Not for a small price, but people started 3D printing everything. They're getting very very good with materials. Every year they come up with new plastic. It's always a bit easier to print, always stronger, always lighter, always more flexible. So it's always been nice to have a bit of an improvement in terms of material. Robots, people print now anything, even with robotics. So any industries that could be something with a robot that they could use in a factory, or that could be even at home. Have your own little robot to do any task or any machines. Especially for disabled people. Sometimes they have these little mini robot arm to hold stuff or hold books or something like that in their home. Everything connected, so that's what they want to try to customize every people's home to have this little robot. Tesla has been doing these little robot as well. Tesla and SpaceX have been using 3D printing, metal 3D printing for a few years now. They started cutting the cost down by using metal 3D printers.
Yeah.
Why learn 3D printing? Well, 3D printing, there's always a little something to create with 3D printing. You always stuck with something, you always need a little something, a little mount, a little bracket, a little something to fix. It's always nice to try to fix and learn new skills on your own before seeking some help or even buying. Sometimes when you live in remote areas or when you really need an item urgently, you can design it in 3D print quicker than waiting for a few days to get it delivered. So it's always nice, and you have a little sense of accomplishment when it's actually done and it works. So when you get the design out and it works and it's strong and it lasts, it's a little bit of a moment when you realize that when you can create an item and sell it, or you can create an item to solve a problem that you have, you might even have people around you that are interested, and you can even create a business out of it if it's something that you like or you're willing to do. So there's a lot of ideas that's already online that you can get. Have a look again on Thingiverse. Have a look what people do. Have a look at around your place if you have anything to fix. I think I've started by fixing even I had a little tripod on the camera that I fixed. So yeah, it could be anything, just a little something that you have on your desk that's been broken that you want to fix. If it's not that complicated, you probably can learn the design and print it yourself.
Yeah.
Do you have any question?
And anyone?
No question? Don't be shy. What do you guys want to print? If we don't have any question, then we probably can have a quick look at the design and the slice. Look, we've got 85 layers, and it's going to be finished in roughly 30 seconds. Oh, wow. We'll let it cool down later, and I'll take it. Ask, please ask any question, guys, if you need. We'll go through the little quick designs first, if you want. In the meantime. So what do we see here on that page? So we have the Autodesk Fusion 360. So we have an actual page, white page that we have here. So we all see all these options here with solid, surface, mesh, sheet metal, plastic, and this is actually the sketch areas. So we can sketch whatever shape we want. So if we can click on create, we have this drop down menu, and all these shapes that you see here are the shapes we can draw. So we can draw a curve, we can draw another curve with multi-point, we can draw a slot, so that could be a straight slot or curved. We can create ellipse, polygon, looks like a beehive, an arc, circle. So we've got all these circles by 2-3 point circles, center, rectangles. We're going to create rectangles from the middle or from the side. So you always come from a sketching plane. So let's just create a little something, a little quick easy shape. So if you can click on rectangle here, click in the middle, we can drag and drop the actual rectangle that we want. This is the actual dimension that we see on the screen, 100 millimeter, which means it's 10 centimeter. Yeah. We can make it smaller. Let's say 25 millimeter by 30. So which means it's 3 centimeter by 2.5. Printing models, aircraft. We've got a question, I guess. Is there a specific site to get information for printing model aircraft? And as your expertise, what's the material we can use to fabricate? Well, they're doing so specific site. I'm not sure. I've never really looked into it. I know that there is a lot of designs already available on Thingiverse that I've seen. A lot of people doing remote control planes, even on YouTube, and they already are sharing their file through Thingiverse. So if you Google or if you look into YouTube, 3D printed remote control plane, you're probably going to see a lot of people already did. Even drones, actually, you can download files of drones frame and 3D printed. I've seen I've downloaded even one and 3D printed the frame for a friend of mine actually that I've printed in PLA. So that, yeah, it is possible to find websites that have the design already ready for you guys. Any other website that you can customize, I'm not sure. But if you really want, depends actually what you want and how big you want to get the plane. Sometimes they already have the design that's done, but the design is usually an STL file, which means you cannot really modify the STL file with the dimensions. Sometimes you're better off by looking at what people do and how they've created the file and try to reverse engineering the actual design that you want to do. So in that sense, you can create your own plane that would be your own file. So you'll be owning whatever file you have. So I would probably try both actually. Try maybe have a quick look on the website to get some inspiration. Thingiverse first. Have a look at Thingiverse again. And what was the other one? Printable. I've seen people creating drones and RC planes. Few of them actually list down the actual component list that you need to buy with servos and remote control, so you have everything ready to buy and just basically plug and play. While while you're printing something, you could order the parts and do your own plane. So yeah, it is possible. And the material, the material you could use PLA first because it's very easy to print. There's another material called light PLA, if I remember correctly. It's just a very light PLA. I think it's slightly more flexible and lighter than PLA.
Yeah.
So it's just basically an alternative of PLA. I think PLA still be cheaper. Light PLA is a bit more expensive. But even these two, the difference is not much. I mean, if it's for very small planes, probably would be worth it to have a light PLA. But if you have a normal PLA or PLA plus, as they call PLA plus for an extra rigidity, I think you'll be well off by starting by using PLA. PLA is a good enough material to start with.
Thanks, Charlie. And thanks, Steve, for asking the questions.
Yep.
I think we'll take a look at also the printer.
Yeah, let's have a look. That should be finished now. So it is finished. Let's load again the video. Yeah, it is finished. It's there all the way down.
Is it possible?
And then I'll go get it. So 91 layers finished. I'll go get it now in the other office and I'll bring it back.
Yeah, so Charlie's just bringing the turtle. Oh, can you hold on. Hello? I can't hear you, Charlie.
Can you hear me now?
Yeah, now I can.
Yep.
Yeah.
So that's a real turtle. So the legs are moving. That's articulated. So if you look back again on the preview. So to give you an idea, that looks like a small object, but compared to the actual weight, can you hear me?
Can you keep it still? I can hear you. Just you can keep it still on your palm. Yep. That's cute. The Charlie and the turtle.
The real turtle. So to give you an idea, if you look at the screen here as well, on my computer screen, this turtle weighs 5.42 grams. So 5 grams is very, very light. That's actually even lighter than a cutlery, than a knife. So it looks pretty big and a bit bulky around the shell, but it just only weighs 5.42 grams. So it's very light. If you 3D print a plane, you're not even gonna print the infill sometimes. You know, people just print whatever they want. They just print the walls, so you'll be even lighter proportionally than that part.
Oh, it looks really cool.
Can you see it well on the screen?
Yeah, like
and the legs are moving. So that's something that we cannot do with injection molding. If you look at the part here, at the preview, let's go on the preview.
Yeah. And
so,
I think another question, Charlie.
There's another question. Yep.
Yes, you had asked. Another question. As per the geometry of the piece, how do you decide feed-in direction of the printer?
Another question. As your geometry piece, how do you decide feeding direction? The feeding direction. What do you mean by that? Feeding through the nozzle.
As in, I think, is it like depending on which way you kind of
right, yeah, what way? That's right. That's a very good question. So how we want to print stuff is this layer line that you see here are always going to be horizontal. So this layer line, you're always going to have the same sort of space between the left and the right, which means the filament here that you will have, if you draw a line, it's always going to be very strong from left to right. But then if you print a little stick standing up, the layer heights that in between, I mean, they're stuck together, but they're not extremely strong. They're not as strong as, let's say, metal or a solid piece of plastic. So the layer height will be very important in terms of strength. So anything that's print horizontally, we always will be stronger than vertically. So the more up you go, the less strong your item, your design will be. So if you have a little stick, or if you have a little ruler, like let's say you want to print that, can you see on the camera? You want to print a little ruler. That ruler here, if you print it flat, it's always going to be stronger than if you print it standing up. When you print it standing up, each layer will be stuck together, but which means you're not going to have this part in one sort of extrusion, in one filament. You're going to have that in different layers, which means it's going to be way easier to break. So if you want to break something that's high through the z-axis, that z-axis, it's always going to be easier to break than if you print something horizontal. So it's always, you cannot have everything of both worlds. If you really want something that's very, very solid and very durable, injection molding is still probably the first sort of option. But some people sometimes started printing on a 45 degrees angle, which means the layer will be sort of spread across. So it's not going to be extremely strong horizontally, but it's not going to be also extremely weak vertically. So I mean, it depends of the actual design. It depends what you want to print. Depends what sort of strength you need to be looking at. If you need to get an item or design done that's extremely strong, you're probably better off by doing with injection molding or CNC cutting. If you cut a piece of plastic into a big block or wood. But in terms of plastic, you probably will be better off by just printing anything you can. If you print something flat, you're always going to have more chance of having a design that's more durable. So that was the sort of the little slice. Yep. So yeah, as I was saying, the little plastic extrusion that you see here, these sort of design that we've printed, it's impossible to print with, to use that as an injection molding manufacturing process. As you see, we've got the body here. There's not attached to the legs. We've got the head. So you starting the 3D printer starting by layering the first layer. Nothing's attached, and slowly as you go up, it goes up. See, it bridged that gap here. So the leg slowly will be attached. See, there's little edge that coming up there. So it's going over this step. So we're going over and we link back. The leg is getting linked again. Sort of a loop. It's just basically like a loop. Exactly how we linked something after. Injection molding would have been a total in one block with no moving parts.
Yeah.
So people now design their own toys and their own little miniature with articulated legs, head, tails, and all these little cute little animals are not available with injection molding. It's just impossible to press. So you got this, can you see it on the screen? Even the tails actually, even without dialing too much, everything is moving and it's fully functional. There we go.
You want to show the turtle again?
Yep. Can you see it well on the screen?
Yeah, maybe keep it on your palm.
Is it better?
Yeah.
I mean, that's great. I should have printed in multicolors, but multicolors takes a bit longer.
Yeah.
I should have printed in green.
Should have. Yes. Cute. Okay. Thanks, Charlie.
Take a photo.
Yeah. Oh, hold on. I took a video, but let me take a photo. Oh, 1 second.
Can you see it well?
Yep. Okay, look at the screen. Oh no, hold on.
Can use the thumbnail.
No, let me do it. Okay.
Good.
Thank you.
Nice.
Nice.
So yeah, we can just finish up with
the
little quick design just to show you what's possible. So I've done my little rectangle here, 25 millimeter, so it's 2.5 centimeter by 30, which is 3 centimeter. We can go on to solid now, and now we've got all these options here. We can fill it, we can extrude, we can do a shell. What we want to do, we want to extrude it, which means from that drawing here, I want to make it 3D. So just pull it up, and we've got a little rectangle. So we've got these like rectangle now, 3D. We can even export it now and 3D print it. So you can then add text on it. So there's an option here under create. You can add your text. You can add, let's say, 3D. Print. We'll make it a bit smaller, so we'll see. At 8. Okay. All right. And then we can extrude it. So when you click on extrude again, we can extrude it outwards like that, or inwards. So we can extrude it by 1 millimeter in. So it's been cut 1 millimeter inwards, and we got your designs here. Then what you can do, you can create a 3D shape by revolving it. So if you click on the line that we have here, line option, you can create now a spline, which means you can create the shape that you want based on the dimension you need. That could be a vase, it could be a holder, it could be anything. You just create something very quickly. Okay, let's link them together like that. Now what we can do, by clicking on solid again, we want something solid. We can revolve under that. So did I link them together? I don't think I did. Okay. Let's go back, Doug. Okay, and we can revolve that one with under this axis, and we have a vase now.
Oh, wow.
Or fountain. That looks like a fountain.
Trying to figure out what you were making. But yeah.
So this is how it looks when you go on the opacity control. This is how it looks inside. So we have a little cavity here that's ready to print, and you can put flowers in. I mean, you know, the dimension is like 3 centimeter. It's going to be a small flower.
Mm.
Yeah, we've got
Yep,
30 millimeter. It's going to be one flower. If you like
one flower. It's gonna be
But yeah, you can create
Like a
whatever
white.
you want.
Yeah.
You can revolve, you can cut that one, you can add your name on it, you can create complicated geometries, you can create screws. So see, if I click on center diameter circle, you have, let's say, a circle of 10 millimeter, which means it's 1 centimeter. Solid, you want to get solid and extrude it. So you extrude it up by, let's say, 35 millimeter, so it's 3.5 centimeter. You can also extrude it from the bottom as well. We want to join up to here, up to the object, up to this face. So you'll have something that's a bit bigger and more solid. So you will have here, if you want to screw it in, let's just go back on the opacity 100%. So you have here a little stick, a little mount. You can put that on the wall and you have a little mount to put something on. Or if you want to design a screw, then you can click on this cylinder and then you can create, thread. So you can create a screw thread as well. So that's sort of these screw thread that you can get ready for 3D print. You got the size you can print as well. So you find a screw thread 10 millimeter, 9. That's the pitch. If you want a smaller pitch, very small pitch, that's 1.25. That's the biggest pitch you can get. So you can get 3D printed objects that you can screw stuff in or out. So if you're on this hole, you can get another thread inside. I mean, that's not a perfect hole. I don't think it's possible now. I should have clicked on that one. That should be sort of possible, I think, to create a thread. And you model the thread. So you have a thread. If you click now on 9 millimeters, you will have a thread that's, I mean, the hole is not big enough, but you could have a thread to get the screw in. Let's put 7, let's put a small thread, so that's good. 4.5 mil, so you got a screw thread inside it. And you got your screw thread in here.
Oh, yeah.
So yeah, guys, have a look what you have online, where you can design all the tutorials on YouTube. And don't really hesitate just to contact Taji or I, and we could take a look at those designs if they want to do anything.
Yeah.
Do you have any other questions, guys, or any other design you'd like to do? Do you have anything broken in your house we have to fix? Let us know.
I'll also share with you guys, like, I think, one of the videos from Charly's van.
Yep.
have like a campo, and I'll just
Yeah, we
share.
can have a quick look.
Yeah.
Yep.
I can just hold on. I had it open somewhere. I'm gonna put it on the chat.
Yep.
The YouTube link. So. Oh no, sorry, not that one.
If you have any other question or any ideas or designs, and if you want to share it.
Draw here. Shoot. Yeah, you can just yeah, this is I'll just put it on the chat.
I've got the English video, AG, if you want. I've got that one in English if you want to share.
This one is not in. I think this one is.
I'm not sure.
It is.
Because I've done another one in English.
Okay.
Oh no, actually no, that's the one. I think. Yeah, that's the one.
Yeah. And yeah, I think I was just all you guys. So pretty much, if you guys are interested in this type of designs and printing and to even learn, you can always contact me. I think Charly, if you go to the slides, I think I can show the
yeah, we can have a look at any other design that you want, or if you want to create the another RC model, have a look online again if you can find any ideas of inspiration.
Yeah, I think this time I'd say like we are also hoping to start maybe in February model plane tours on RC model planes. It's like a 5-week maybe hybrid tours, so students can join online as well as come physically and do the hands-on practicals as well. And I'll be incorporating a little bit of 3D printing into that, as well as we'll have another like a separate one where you can just come and learn how to use maybe AutoCAD and a little bit of design. And then like Charly just showed you, there's so much you can technically print, whether it's parts for a small aircraft with like a smaller scale, or whether it's for cosplay at this point, like if you want to have some cool costume designs, or whether it's actual, like he showed, like those the handy ones where like a gearbox, or where it's a part that's broken. I think Charly has something that he bolted onto his fridge, which is broken by just printing.
That's right.
Or even things like, I mean, anything's possible. Like, even this type of like, phone holder, or like anything you really want to, but you can just sort of learn how to. And even some of the sites and the links, if you want any clarifications or any resources that I can share, you can email me at arjun@hybrid-ed.com, or call or WhatsApp on this number 0779191975. You can take a screenshot. I think if you go, Charly, onto the next slide. Yeah, I think we have the contact information on the one after that as well.
The contact info, yeah.
Yeah, and also for Charly's company 3D Pro Tech, you can actually take a look at his Instagram.
Yep.
He has actually shared some cool stuff on there as well, and you can see the type of things that he's been printing. So, and like we said, I can also maybe reshare like the resources of where you can find these tutorials, or like if you want to learn by yourself, or some of the links that we showed earlier, where you can download if you don't know how to design as well directly.
Yeah, I think we can go back. So yeah. Don't hesitate. Just take a screenshot of that one. Take a quick photo.
Yeah. And also for the courses, the thing is, I think we have limited seating available. And so whoever that joined today, I would like to anyway, like, if you want to share it with any of the friends, I'd love to, give you like a sign up form, so you can actually just directly sign up, because it's going to be limited seating available, like on a first come first serve basis, but I would try to prioritize you. So you can just put in the details if you're interested, or like contact us through like the hybrid Instagram, or like I said, the email, or on WhatsApp, and I would get back to you, and we would be having a 3D printer soon, so that you can come and also utilize it, learn how to use it, or like just see what's possible. Yeah, but thank you so much, Charlie. If you have
No
anything
worries.
left that you want to just touch on, or anybody else who has any questions or any feedback, anything that you would like to share, you can raise your hand and I can unmute you, or you can just leave a message on the chat, whichever that's comfortable.
Yep.
But everybody, thank you so much for joining and actually for
Thank you
staying
very much.
all time. And Sally, you were amazing. I think you're very
Thank you very
clear.
much.
I'm always amazed by whenever I talk to you, I talk about something completely different. So like,
Yeah.
yeah, and I'm pretty sure there's so much more you can share just on the dental and which I got very interested in as well about
Mm.
implants. So,
Yeah. There's always new stuff to learn. Always. Every day they're coming up with new machines, new materials. It's hard to keep up sometimes, but yeah, at least I'm trying.
yeah, and actually, if you want to just show you the camp, I think everyone can just get an idea as to why I think he's pretty like good in all areas of things. Do you want to play that quickly?
Which one?
The YouTube video.
Sure. Yeah. Yep.
Yeah,
I mean, with the van.
yeah, yeah.
Yeah. I don't think. Can we click on it? Can I copy pasted it here?
Yeah.
Let me have a look if I can copy paste in another browser.
We can, if you just play it on the. It's on the chat.
Yeah. Because now I've got the sound. Let me have a look if I can.
Oh, I can share it as well, but I think it didn't. Oh, that's it's good now.
I think I've got the sound on over it. I don't really hear what's happening now, but
No, it's playing now. Yeah. You on the. It was playing earlier. Oh yeah, here you go.
yeah.
So I think this is the one that you bought and you kind of just turned it into a camper van. So
Yeah.
I think you can talk over the video because I think we can't hear the sound. How long did it take for you to?
Hang on, let me just try to cut the sound because I'm struggling to hear you guys.
It's okay, you can just play it. So I think we can't hear the sound.
Oh no, there's a sound playing at the back, but I'm struggling to stop it.
I don't think anybody hears any sounds right now. It's okay, Charlie. You can just play it without the
Not
audio.
sure.
Yeah, just play it. And when it's done, I'll
Yeah.
ask you.
I just play it and I might just
Yeah.
close the browser because there's something playing out the back that I can't really cancel. I'll just maybe pause it. Here we go. That's it. I got the sound back. I couldn't hear you for a second.
Okay.
Yeah, all good. I'm just playing it like that, so at least you guys can see. Can you see my screen?
Yeah, we can. And I was just asking how long it took for you to do the whole project, like the van.
It took me.
Because you were doing it.
I think, but look, I wasn't doing it full time. I've done it a few parts here and there after work hours. So it took me couple 3 months, something like that, because I was doing half an hour, 1 hour max every day. On the weekend, a little bit more.
Yeah.
So it took me a while because I had to, clean it, make sure I've done a full checkup on the van as well. I got some tools as well. I've ordered some tools as well. Ordered a few drills. So I didn't have all the tools available, but slowly I got my hands into wood cutting and all this stuff.
Yeah.
So I had to buy a few tools as well. So that's why it takes long. Sometimes I was getting some screws, and 2 or 3 days later, I just realized, I don't have enough. So I had the wrong screws. So I had to go back in the shop to
Mm.
buy some more. So that was a long process. I could have done it a little bit quicker, but I like to just take my time and just do it like that. So this is me cutting a few stuff. This is how I've done the bed frame with aluminium extrusion
Mm.
and with wood as well. So there's like a little double bed. A few staples. So that's like a little bed that you can retract.
Oh, yeah.
And to go fast forward, this is how I put this is just basically vinyl on the floor.
Mm. And I think the earlier one on the video was from here, right? Your the light box that you printed 3D.
Yeah, that's right. This is yeah, that's it. That's on the with the LED. That's the LED strips that I've glued on
Yeah.
for the light. So that's what it looks like inside when I was doing the soldering.
Mm.
So you got the light switch now. This is what I've done here. So you've got the dimmer switch for the light.
Yeah.
You can dim the switch down, just dim the light down.
Yeah.
Light in the USB that I showed on the video. That's the wood. I varnished the wood a bit just to make it a bit more shiny.
Mm.
Storage. And it's almost fully finished.
Nice.
This is the bed. Bought the foam. And I tried it like that. Done.
Nice.
I was on the phone that day. So yeah.
All right. Thanks for sharing that, Charly. And
That's okay.
yeah, and thank you so much for the time today. And I think I hope everybody found it very interesting and useful, and maybe gave you some insight into 3D printing that, from a particular lens, or like things you didn't know about, and actually also into a bit of dental, like molding of, teeth as well, which was interesting.
It's always nice to learn new skills.
Yeah, and thank you so much, Charly, for your time.
Thank you.
Sharing. And like we said, anyone who's here, thank you so much for joining and staying this whole time, because I think we went past 12. So, but I think it was interesting because no one's left. But yeah, if you have any questions, feel free to email me or WhatsApp me or Instagram me as well. I think you can find maybe if you want to take a screenshot of like Charly, if you want to go to the slide just for a bit, that one, and also maybe check out Charly's Instagram as well on 3D Pro Tech.
Yep, that's right.
Yeah, and you can find Hybrid on Facebook and Instagram, and you can find Charly at 3D Pro Tech on Instagram. And you can email us on this, and I'm just going to send hold on, I think I'm just going to put this sign up form which I have already on chat if anybody you would like to join one of the courses that are upcoming, or if like has anybody that would like to, you can share it with them, because I haven't officially shared it with anyone yet, so I can make sure I try to give priority for the first come first serve, on a first come first serve basis. So yeah, but once again, thank you so much. I hope you all really enjoyed, and Steve, thanks for all the questions, and Dee, thank you, and Timothy, and yeah, I think everybody, thanks for joining. Thank you so much.
Thank you very much. Thank you for having me, Aji. See you soon.
See you all. Have a good day. Bye bye.
Bye bye.